This quiz was on functions and polynomials. First question, given that 3x plus 2 is a factor of this function, we want to show that a is equal to 5. Now what this means, when this is a factor of this function, it means that when you get this factor, you take into this function, what should be the remainder? No, 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 no. So this one is a factor of this function. So if I divide this, if I said 8 is a factor of 16, if I take 8 into 16, what will be the remainder? The remainder will be 0. So every time you hear of factor, then the remainder is supposed to be 0. So I'm going to get this factor 3x plus 2 equated to 0. Then x is going to be negative 2 over 3. So if I get negative 2 using the remainder and factor theorem, remainder is equal to f of x. So because this is a factor, then the remainder is going to be 0. Okay, and that will be equal to, I'll go into f, we have got 3. Where there is x, I'm going to put negative 2 over 3 to the power 3 plus a. Where there is x, I'll put negative 2 over 3 to the power 2 minus 4. Where there is x, I'm going to put negative 2 over 3 and then minus 4. So here I've got 0 is equal to 3. Negative 2 to the power 3 is negative 8. 3 to the power 3 is 27. And then plus a. Negative 2 to the power 2 is 4. 3 to the power 2, that's a 9. Negative 4 times negative 2 over 3, that is going to be positive 8 over 3. And then minus a 4. Now, the badness is it's taking a bit of time to show. Okay, good. Are we together so far? So this will be 0 is equal to 3 can go into 27. That is going to be 9 times. And then plus a times 4 over 9, that is going to be 4 over 9a. And then plus 8 over 3 minus 4. So what I'm going to do is I'm going to take all the terms which doesn't have a to the other side. So we are going to have, I'm remaining 4 over 9a. Okay, so I've remained this side. So if I take this term the other side, it becomes 8 over 9 positive. If I take this term the other side, becomes negative 8 over 9, over 3. I take for the other side, becomes positive 4. My aim is to have this is 9 in the denominator. So my aim is to have 9 as the denominator of everything. So 4 is the same as 4 over 1. So how can I make 3 to be a 9? What number should I multiply by 3 to have 9? So I multiply on top by 3, also down by 3. And then what number should I multiply by this one for me to have 9? Okay, so multiply on top by 9, also down by 9. My aim is just to make the denominator the same. So I've got 4 over 9a. This is equal to, since the denominators are the same, 9, we just add what's on top. So on top we're going to say 8 minus 8 times 3 is 24, right? And then 4 times 9, 4 times 9 is what? Is it a 36? Uh-huh. 36, isn't it? Ah, you don't know that is, yes, it's the 36. Okay, from there, let's add 8 minus 24 plus 36. What are we going to get? 20. Now, since the denominator is the same, 9 is equal to 9, meaning also the numerator should be the same. 4a should be equal to 20. And this will give us that a is equal to 5. Is that good? Hence, shown. So, questions given to say show, please, it's just important to just say hence shown. at the end. For some of questions like this, for not saying hence shown, you lose a mark, especially when you are proving rationals, binary operations, those. If you don't write the last statement, you are going to lose a mark. So make sure that you just do. All right, so we have shown that a is equal to 5, and then when a is 5, we want to factorize f of x. Now, how will be f of x? F of x then is going to be 3x to the power 3. Where there is a, we've already found that's 5x squared minus 4x minus 4. So I'm going to use synthetic method. Equate this to 0. Equate this to 0. What is the value of x? X is equal to? Friends, what do you get when you equate this to 0?
So we can't see it's one side. So the first part we cannot see. We just see 5x squared. The other side we're not seeing.
When you equate 3x minus 2, you can't see the 3x minus 2. Okay, you are going to, when you equate 3x minus plus 2 to 0, you're going to get negative 2 over 3. Let me just check. It seems the network is jamming with what's on the board. Okay. Are you able to see now? Okay, good. So I've equated to 0 and I found the value of x, and then I write this. Remember, I want to use the synthetic method. The network is just become slow, so I don't know how I'm going to manage this. My voice might be okay, but it is slow when I write. Okay, I'm going to get the coefficients of the function starting with the highest power. So can you give me the coefficient? What is the coefficient of power 3? Yes. Please go on. Give me the coefficient. Esther, go on.
I can't see what you're writing on the board.
You can't say anything.
No, I can't.
What's appearing on the board? Is it showing anything? What's appearing? Are you able to see anything? Or nothing is appearing?
Okay, I'm able to see now.
Okay. So, can you give me the coefficients of this function from the highest power to the constant? We have got 3, we have got 5, we have got negative 4, we have got another negative 4. Are we good? You people, you are too quiet. Are you not able to see? Why are you being quiet like that? So I'm going to put a 0 here. I'll add 3 plus 0, that is going to give me a 3. And then I'll multiply this 3 by the negative 2 over 3, that will give us a negative 2. Then 5 plus negative 2, that will give us again 3. Then 3 by negative 2 over 3, that will still give us a a negative 2, negative 4 minus 2, that will give us negative 6, negative 6 times negative 2 over 3, that is going to give us a negative 4. So if I get to, did I even write something correct here? Okay, it's going to be positive for negative 6 times negative 2 over 3 is positive 4. So if I add negative 4 plus 4, that will give us 0. So the remainder is always supposed to be 0, which you're able to see there. So the first number that you have found is going to be the coefficient of power 2. This is going to be the coefficient of x, and then I've got a constant. Meaning if I get to factorize this function, the first factor that we have, remember, is the same one which is been given, which is the 3x plus 2. That is the first factor. Are we moving together? We have got some questions. So the first factor is 3x plus 2. And then what we have found from the factorization here, we have found 3x squared plus 3x minus 6. So we have factorized like this, though it is not complete. Are we good so far? Marco, is it okay, Esther?
Yes.
Okay, so now let's factorize 3x squared plus 3x minus 6. For that, I can also factorize out a 3, and then we're going to remain with x squared plus x minus 2. So the product that we have here is negative 2. The sum is 1. What numbers can we multiply to get negative 2? When we add them, we get a positive 1. Do you know of any? Esther, any?
Only my network here is tripping.
Oh, that's sad. It might be maybe here. Marco, are you able to get me?
I am, but it's breaking. So there are times you just go quiet and then you come back just like that.
It has changed. I think it's period. It's period. So this period is not for internet. So in case it to continue like that, I can just finish these questions just like this, and then you can follow the tutorial I'm going to send. So two numbers I can multiply to get negative 2 and add, we get a 1. That should be, yes, a positive 2 and a negative 1. So meaning factorizing this would be x plus 2 and then x minus 1. Remember, we have got a 3 which is outside here. So this is going to be, I'm going to write first that 3 which is outside, and then we have got 3x plus 2, and then we have got x plus 2, and then we have got x minus 1. Now I've written this 3 in front because multiplication is commutative. It doesn't matter where I start writing that 3. It will all be the same. Okay, the next question is saying, hence sketch the graph of f of x, determining or indicating the x and y intercepts and also the turning point. So I'll go into the sketching. Equate this to 0, you have found that x is a negative 3, negative 2 over 3. When you equate this to 0, you're going to find that x is equal to negative 2. When you equate this to 0, you're going to find that x is equal to positive 1. Okay, so what we have here, I'm going to write a diagram that is showing signs. I'll write the factors that we equated to 0. We equated 3x plus 2, x plus 2, and then x minus 1. The values that we found, the smallest is negative 2, the next is negative 2 over 3, the next is a positive 1. When I equated x minus 1 to 0, I found 1. So anything above 1, putting in that function, it will give me a positive. Below 1 will give me a negative. When I equated x plus 2, 0, I found negative 2. Anything above negative 2 is going to be positive, and anything below is going to be negative. When I equated 3x plus 2 to 0, I found negative 2 over 3. Anything above is going to be positive. Anything below is going to be negative. Now we want where this, the product of the signs, because these functions you can see from here, they are multiplying. So negative, 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 that will be negative. This is going to be positive. This is going to be negative. This is going to be positive. So this is now what we're able to sketch. So x there, then 1 here. Okay, so we have got negative 2. We have got negative 2 over 3, and then we have got positive 1. We know that for all values of x less than negative 2, the function is negative. So meaning that is going to be below. Between negative 2 and 2 over 3 is positive, meaning it's going to be above here. And then between negative 2 and a 1, it's a 1. I mean it's negative. But remember also I've got the y-intercept is negative 4, so meaning that is it will come and cut also negative 4. So it's supposed to pass like that. Negative 4 is not a turning point. That is where it will just get to cut. So before then, let me also remove this so that it will not confuse our operation. So this is going to go like that and then come back like this. But where it is cutting, this is supposed to be negative 4. And then above 1 is supposed to be negative like that. So this is how the function is going. For the turning points, I'm not going to find them because you use calculus and that's not, we've not done calculus yet. Simply differentiate this and then equate it to 0. Find the x values. When you find those x values, come back to this function. The x value that you find, substitute here to find the y value. That will be the turning point. Okay, we have got this one. When the polynomial p of x, which is x to the power 3 plus kx squared minus 2x plus 1, is divided by x minus k, the remainder is k. Find the possible value of k. When you divide it by x minus k, the remainder is k. So let's equate x minus k to 0. We are going to find that x is equal to k. Using the remainder theory, we know that remainder is equal to f of x. And we've been told that the remainder is k. So where there is r, I'm going to put k. And then remember, equated x to 0, found x to be equal to k. So I'm going to go into the function. Where there is x, I'm going to put k. So that will be k to the power 3 plus k, open brackets. Where there is x, we are going to put k to the power 2 minus 2. Where there is x, we put k plus 1. So I'm going to take all the terms to the same side. 0 is equal to k to the power 3. This will also give us k to the power 3 minus 2k. If k goes the other side, that will be minus k and then plus 1. We want to have 0 is equal to 2k to the power 3 minus 3k plus 1. Okay, like that. So using synthetic method, let's get to find the value of k. So the first thing, let's say if k is equal to 1, if it will give us 0. So this is going to be 2 minus 3 plus 1. Is it giving us a 0? Is that going to be equal to a 0? Anyone? So when k is equal to 1, we are saying we are finding a 0. Let's find now the other factors. So I'm going to write now the coefficients of these powers. The coefficient of power 3 is 2. Then next we go to power 2. We don't have power 2 here, so the coefficient is 0. And then we go power 1, the coefficient is negative 3, and then 1. I'll put a 0 here. 2 times 2 plus 2, 0 is 2. 2 times 2 is 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2, negative 3 plus 2 is negative 1, negative 1 times 1 is negative 1, and then 1 plus negative 1 is 0, which is a remainder. Meaning that this one, factorizing it, is going to be this k is equal to 1. If I write it as a factor, I'll take 1 the other side, it will be k minus 1. And then this one has also remained. This should have power 2, and then this should just be a constant.
Yeah, you are too fast.
I thought you people are not following because you are not answering me. Okay, where is there anywhere I need to repeat or I just slow down?
Just slow down. Slow down.
Okay, so we have now found this. So this written as a factor is going to be 2k squared plus 2k minus 1, and this is going to be equal to 0. We need also to factorize again this, which we have this quadratic. The product is a negative 2. The sum is a positive 2. Do we have two numbers we can multiply to get a negative 2? When we add them, we get a positive 2. We don't have. So meaning is only this one that we are going to equate to 0, and that will give us a positive 1. For this one, we can try to see if we can find solutions by finding the discriminant, which is square root b squared minus 4ac. So b is 2 squared minus 4, a is 2, c is negative 1. So it's going to be 4 plus, this is going to be plus 8. That will give us square root of 12. So we are going to be able to find answers also for this one. But those answers that we are going to be able to find are not real roots. Okay. I mean, they are real roots, but they are not integers. Let's find, because the question is saying find the possible values. It's not just the value. So you say k is equal to negative b, negative 2, plus or minus the square root of b squared, that is 2 squared, minus 4a, which is 2c is negative 1, over 2a. So k then is going to be negative 2 plus or minus what is inside is going to give us a 12 divided by 4. So k then is going to be 2 plus or minus. We know 12 is the same as 4 times 3, right? And you know square root of 4 is 2. So this is going to be 2 root 3 over 4. Are we together up to this end? Are we together? Okay, so k is going to be, I'll factorize out a 2, so we're going to have 2 open brackets, 1 plus or minus square root of 3, and then divided by 4. So a 2 can cancel with 1 here. So k then is going to be 1 plus or minus square root of 3 over 2. These are going to be the solutions. If I want, I can split this into two solutions. So that is it. Okay, so for the next one, given that alpha and beta are the roots of the equation 3x squared plus x plus 2 is equal to 0, find the equation whose roots are 1 over beta and 1 over alpha. Now, first thing first, you always need to find the sum alpha plus beta. Alpha plus beta is given by negative b over a. And from the equation that you've been given, what is the value for b? From the equation. Okay. Hope you are able to see from the equation what's the value for b? Okay, so that will be negative 1 over 3. And then let's find alpha times beta. Makua, how do you find alpha times beta? Okay, C over A. And C is 2, A is 3. Now we can look at the roots. So we're going to find the sum of the roots. We can see we have got 1 over alpha. We add 1 over beta. This is the same as making as a single fraction. What is on top of the first multiply with what is down the second, like that, and then multiply the two denominators. Now alpha plus beta, we have found negative 1 over 3. I'll say divided by alpha times beta, we have found 2 over 3. So basically this will give us negative 1 over 2 because the 3 will go on top, the 2 comes down. Okay, that will be it. And then we also need to find the product of the roots. Product, you have got 1 over alpha multiply with 1 over beta. So basically what we have is 1 over alpha beta. So this is going to be 1 divided by, what is alpha beta? Alpha beta is 2 over 3. And if we change this direction, that will give us 3 over 2. Okay, we want to find the equation having these roots. When you're writing the equation is given by x squared minus sum x plus product is equal to 0. We're going to be x squared minus sum, that is negative 1 over 2, x plus product is a 3 over 2 is equal to 0. To do away with the fraction, since we have got 2, I can multiply everything by a 2. So it will be 2 times x squared, that will be 2x squared. This negative and this negative, that will give us positive. These two cancel with this denominator, so that will just be x. And then again it will cancel this denominator, that will just be positive 3, and that will be equal to 0. So this is the equation. We are good? Are we? Okay. Find the real value, for the real valued function h defined by 2x over 5 minus x. Find the range of h. Find the range of h. So if you want, just find the inverse of this function. The inverse you are going to get, if you find this domain, it will be the range of this function. So the domain of this function, you just get the denominator, it can't be equal to 0, meaning that it can be anything but not 5. Now range, I'm going to say y is equal to 2x over 5 minus x. Cross multiply, you're going to have 5y minus xy is equal to 2x. And then take those terms with x to the other side. Going to have 5y is equal to 2x plus xy. Factorize out x open brackets 2 plus y. That is going to be equal to 5y. So x is going to be 5y over 2 plus y. So the denominator can't be equal to 0. So say 2 plus y cannot be equal to 0, meaning that y can't be equal to negative 2. So therefore, the range of the function can write it as y is a member of real numbers such that y is not equal to negative 2. Sorry, all this I've been saying wasn't visible. So that is how you get to present the range. Do we have a question? Can I proceed?
Yes, you can proceed.
Please, these questions are going to come in the test. Just make sure that you understand. They'll change numbers, but the questions are going to be the same. Determine whether the function is one-to-one. So if you want to determine one-to-one, you say f of a is equal to f of b. At the end, you should get that a is equal to b, then it is one-to-one. So you say 2, where there is x, put a over 5 minus a is equal to 2, where there is x, put b over 5 minus b. Cross multiply. 2a times 5 is going to be 10a. 2a times negative b, that is negative 2ab. That will be equal to 2b times 5, that is going to be 10b. 2b times negative a, that will be negative 2ab. Take everything to the same. Okay, let me take like terms to the same side. What are our like terms here? Negative 2ab and negative 2ab, if they go to the same side, they'll cancel. So I'm going to remain with 10a is equal to 10b. Divide both sides by 10, a is equal to b. So hence function f of x is 1 to 1. So when you just find that a is equal to b at the end, then the function is 1 to 1. But if you find that a is equal to b and a is equal to negative b, then the function is not 1 to 1. It is mean to 1. The next one, we want to find h of x. So you have got h of x. So we're going to get h, which is 2. Where there is x, we are going to put h, which is 2x over 5 minus x, divided by 5 minus, where there is x, we are going to put 2x over 5 minus x. This is going to give us, a multiply on top, we are going to have 4x divided by 5 minus x. I multiply these 2 with these 2. That is where the 4 has come from. Instead of me writing this over, let me say divided by. I'm going to merge this as a single fraction. So this is over 1. So this, let me write it here, 5 over 1 minus 2x divided by 5 minus x. I'll multiply what is on top, 5, by what is down, that will be 25 minus 5x, and then I'll multiply the negative 2x with the 1 minus 2x over 5 minus x. So this is going to give us 25 minus 7x. Yes, please. Sure, go on.
Sorry to get you back. Where is that two coming to?
Which one?
On top there.
This one?
On top there.
Do you mean this one?
On top.
This one?
Yeah, on top. Where there is F of, yeah, that's what I mean.
Okay, that 2 is this one, which is in front. This one. Are you able to see it?
Yes, you factored it out.
So no, remember we want to find h of h, right? So I'll write these 2, but where there is x, remember we are substituting h, okay? We are finding h of h. So where there is x, I'm putting h. I'm putting again this whole function. Do you see that? Are you able to notice what I'm talking about?
H of H.
Yes. So good. And then I'm going to swap this. This is going to be 4x divided by 5 minus x. And then we change it to times. The 5 minus x goes on top, and then the 25 minus 2x, 7x comes down. So this 5 minus x will cancel with 5 minus x. We're going to have 4x divided by 25 minus 7x. And that is going to be it.